Okay, so somebody's asked me to solve this problem. 3 raised to the power of y minus 1 is equal to 21. Okay, so it looks rather intimidating, but it's actually fairly straightforward. But before we can even begin to tackle it, there's some background we need to worry about. Welcome to the laws of indices. What are indices, you ask? Well, no, you weren't asking because you probably know, but some people might be asking. Okay, so first of all, let's look at multiplication and addition. Let's say we have 3 plus 3 is equal to 6. We could say 6 is equal to 2 lots of 3. 3 has been added to itself twice. So we could say that this is the same as 2 times 3. 2 lots of 3 is equal to 6. We could also say that 3 times 3, which is equal to 9, is the same as 3 plus 3 plus 3. That is to say that there are 3 lots. Oh, I can't draw. 3 lots of 3. Let me see if I can. There we go. So that 3 is counting how many 3's there are, and this 3 is saying what the number that's added to itself over and over again. Okay, so this hopefully everybody knows. And we can also say that, say, 4 times 6 is equal to 4 lots of 6. So that's 6 plus 6 plus 6 plus 6. Okay, so that's what times does. It's basically adding something to itself over and over again. It's repeated addition is multiplication. And of course, if we wanted to go backwards, the opposite of multiplication is division. So if we say 4 times 6 is equal to 24, and we want to know how many lots of 6 we need to make 24, we could say 24 divided by 6 is equal to 4. And if we wanted to know what number you need 4 lots of, you could also say 24 divided by 4 is equal to 6. So division's like the opposite of multiplication. Okay, so but what happens if we have repeated multiplication? For example, we have 3 times 3 times 3. Well, a shorthand way of saying 3 times 3 times 3 is to say 3 raised to the power of 3, which of course is equal to 9 times 3, which is 27. Oops, that should read 27. Excuse my handwriting. I was never any good at handwriting. I spent more time in detention doing handwriting exercises than any other kid in the school, and I've never been able to get good handwriting. Okay, so what if we have 2 times 2 times 2 times 2? Well, that is the same as saying 2, and there's 1, 2, 3, 4 2's, so that's 2 raised to the power 4, which is equal to 8. 2, no it's not, it's equal to 16. What's wrong with me? Where's my brain? Here, brain. Where did I leave my brain? Okay, so that's 16. Okay, and then we can say that's 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. There we go. Okay, so that's basically what an index is. Now let's say we want to go backwards. Well, just like division was the opposite, we have two different functions that can take us backwards. So let's say we have 3 squared is equal to 9. Now let's say we know about the 2 and we want to find the 3. So let's say that x is the unknown quantity and we know that x squared is equal to 9. Well, the way to do that is to take the square root of both sides. That should be the square root of x squared. And that will bring us, well, unfortunately, because negative 3 times negative 3 is also 9, if we want to be absolutely clear about what x is, it could be either positive or negative. And we need to write the positive or negative there because the square root function only returns the positive result. So then we can say x is equal to plus or minus 3. But we know that it was actually the 3, so it's actually the positive one that we actually wanted. So if we have a raised to the power b, then this is called the base, and this is called the index. I better get that out of the way. So the number that counts how many times the number is multiplied by itself is the index, and the base is the number that's multiplied by itself over and over again. Okay, so that much we've got. Now, we know how to solve x squared is equal to 9, but what if we wanted to do it the other way around? What if we had 3, which we know, but we didn't know that it was squared? So we had 3 raised to the power of an unknown quantity is equal to 9, and we want to find the x. Well, we have another function, just like square roots, that can get us backwards. We need the logarithm. So in this case, it would be the log to base 3 of 3 to the power x is equal to x, which is equal to the log to base 3 of 9. Great. Unfortunately, calculators don't do logs to the base 3, so we need to understand one of the laws of indices. Or rather, this is actually a law of logarithms. And this is called the base change formula. The log to base a of b is equal to the log of any base of b divided by the log of any base of a. That's the base change formula. It's just worth knowing for when you use a calculator. Okay, so let's go back to our problem of 3 to the power x is equal to 9. I'm going to move this up. And I'm going to say that the log to base 3 of 3 to the power x is equal to the log to base 3 of 9. So x is equal to the log to base 3 of 9. And how we write that on a calculator, we would say x is equal to log 9 divided by log 3. And let's pull up a calculator and see. Okay, I've got my calculator, so I'm going to type 9 log and then divide by 3 log and press equals, and it says 2. So x equals 2. I mean, we knew that anyway because 3 squared is 9, but it's good to see how logs work. Okay, I think we now have all of the basics that we need. But let's just do one more thing just to be safe. Let's say 3 raised to the power 2, and now what we want to do is multiply this by 3. So that's basically saying 3 times 3, which then has to be multiplied by 3. Well, now we have 3 3's, so this is equal to 3 to the power 3. And that leads us to one of the laws of indices, where if you have a raised to the power b and you multiply it by a, all you do is add 1 to the index, so that's just equal to a to the power b plus 1. In fact, we can generalize this and say a to the power b multiplied by a to the power c is equal to a to the power b plus c. And if you just want to get some idea of how that works, let's say 2 cubed multiplied by 2 to the power 4 is equal to 2 times 2 times 2 times, that's 3, times 4 lots of 2, 2 times 2 times 2 times 2, which is 4, which is equal to 1, 2, 3, 4, 5, 6, 7, which is 2 to the power 7, which is the same as 2 to the power 3 plus 4. Okay, I think we've done enough basics to be able to solve the problem that we were given. Okay, so this is our problem. 3 to the power y minus 1 is equal to 21. So let's see if we can make this problem a little bit easier to solve by having it in the form of 3 to the power x. Let's have it in the form of 3 to the power x is equal to 21. Because that's a bit easier to solve, isn't it? Because then all we need to do then is find the log to base 3 of 3 to the power x is equal to the log to base 3 of 21, and so then we've just got x is equal to log 21 divided by log 3, which we've already seen. So that would be easy. So all we have to do is say x is equal to y minus 1. That's a simple enough thing to do. And so when we've solved this, all we have to do is add 1 to the value of x to get our answer. But you know what might just be a little bit quicker, or what I think is a little bit quicker, is remember if we multiply by the base, we're adding 1 to the index. So if we multiply by 3, is equal to 3 times 21. And now, if we multiply by 3, 3 to the power y minus 1, well, that's y minus 1 plus 1. The minus 1 and 1 cancel out, so we've just got 3 to the power y. So this is 3 to the power y, because we're just adding 1 to the index. And that's equal to 3 times 21. Well, 3 times 2 is 6, and 3 times 1 is 3. So 3 to the power y is equal to 63. And now we just go through the motions because it's dead easy from here on. This is just log to base 3 of 3 to the power y, which is just y, and that's equal to log to base 3 of 63. So that's just y is equal to log any base of 63 divided by log 3, and from there we just grab our scientific calculator. Instead of saying equals, I use this wavy equals, which means approximately equal to, because I know this is not going to come out as an easy integer number. So we've got 63 log divided by 3 log, and that's equal to 3.7712437 whatever. Let's just round that off to 3.77. Equal to 3.77 approximately. Okay, I hope that was helpful, and I want to wish you every success with your mathematics. Enjoy yourselves and have a good day.